Okay, today we are going to practice our implicit differentiation by differentiating y cosine of x is x squared plus y squared, and we're going to differentiate that dy dx. Okay, so the first thing that we're going to do is we're going to just start differentiating both sides of the equation. So we're going to take dy dx of y times cosine x, and that's important because that means there's going to be a product rule here. We're going to derive x squared with respect to x, and we're going to derive y squared with respect to x. There's going to be a chain rule hidden on the y squared, and the reason that we're deriving each one separately, you probably know if you're watching this video because that was a couple subjects back probably from implied differentiation, but the derivative of a sum is the sum of the derivatives. So our next step, we're going to do the simple ones, and then we're going to work ourselves out to the slightly harder ones, but we're going to write it all down as we go. This is going to be y prime times cosine x plus cosine x prime times y equals 2x, because that's just going to be the power rule, plus, and now we're going to have a chain rule, so I'm going to put it in brackets to keep it really clear, dy squared over dy. So we're going to derive y squared with respect to y and multiply it by dy over dx. And this is just the chain rule. So y is the inner function, x squared is the outer function. So here we go. And I'm going to change colors. So what we're going to end up with here is cosine x times dy over dx, which is our slope of the tangent lines. In the end, that's what we're going to be solving for, plus negative y sine x. And the reason for that is that the derivative of cosine x is negative sine x. I'm going to pull the y to the front. I'm going to pull the negative to the front. It just looks nicer that way. It's the same thing though. 2x plus, now the derivative of y squared with respect to y is 2y times dy over dx. So notice here that we have two dy over dx's, right? We have this twice. We have this over here and we have this over here. We want to isolate those. So we need to get them on one side and everything else on the other side. So we're going to factor by grouping. So the first thing we're going to do is we're going to get them all on one side. So we're going to add y sine x to the right and subtract 2y times dy over dx so we get it on the left. And we're going to end up with cosine x, that looks like an O, cosine x times dy over dx minus 2y times dy over dx equals 2x plus y sine x. So now I'm going to change colors again. Now we're going to factor by grouping. So what we're going to do is we're going to factor out dy over dx on the left side, and we're going to end up with dy over dx times cosine x minus 2y equals 2x plus y sine x. Now we're going to divide by this entire thing right here so that we can have dy over dx on one side, and that means we will have solved for the derivative of y cosine x equals x squared plus y squared is going to equal 2x plus y sine x over cosine x minus 2y, and that's our solution.